it's kind of a statistical look at it, actually. So, first we're going to look at a geometric series and see how we can quantify that error, and then we'll look at the broader, like, Taylor series and see how you would quantify that error. First part's easy. So, we want to quantify our error. Okay, first let's look at a geometric series. Okay, quantify obviously means give a number to, assign a value to how much error that we have. So let's take a geometric series. I took this one. I'm going to take 1 over 1 minus x squared. So it's just a little manipulation of like your basic geometric series. You should kind of know what this looks like. Just because you have the first one hopefully starting to be memorized. But geometric series are so easy to write that you don't really have to memorize it. The first term is going to be what? 1, and the r is going to be x squared. So this geometric series is really easy to write. So we got 1 plus x squared plus x to the 4th plus x to the 6th. And I'm going to stop there. So let's say I'm asked to find a 6th degree geometric series for the first 4 non-zero terms of a geometric series, and it would stop here. So just to kind of also make a note, sometimes they call this the 4th partial sum. There's a couple different ways to word it. A 6th order polynomial, or the first 4 non-zero terms, or a 4th partial sum. You kind of get the hang of it as we look at some other problems. But the error for this is like the amount that's thrown away. Okay, which is an infinite amount, but we still want to try to kind of quantify it. So the amount thrown away, well, if we stopped here, what's the first term of my new series? Let's say I want to write a series for this error, or I want to look and see what values did it involve. Right, so I start off with, in this case, x to the 8th. And the next term would be x to the 10th, and the next term would be x to the 12th. This is all the stuff that I didn't use, right? If I just have the first 4 terms, I still have left all of these terms, x to the 8th, all the way up to x to the infinity. Well, this in itself, this is a new geometric series. It just starts in a different place. This has an a value of x to the 8th and an r value of x squared. Amount. Oh my gosh. It's like abbreviated. Okay, so the amount I didn't use is x to the 8th all the way up. So this is kind of a new series where the first term is x to the 8th and the multiplier is x squared. Get it so far? Okay, well we can find the sum of this. What is the sum of the, I'll say like the remainder? Sum's going to be that x to the 8th over 1 minus x squared, right? This is an algebraic notation for the remainder, all of it that's left after x to the 6th. Well, the reason why it's variable, the reason why it's changing, is because depending on what x value I'm at will change the amount of error that I have. Where does this thing converge? From what to what? What x value to what x value? Negative 1 to 1, right? This converges from negative 1 to 1. I don't know what this looks like. Let's just say, I'm going to totally get it wrong. Whatever. Let's just say it looks like this. 1 over 1 minus x squared, let's just say it looks like that. Well, then let's say the series, for only those 4 terms, let's say it goes like this, and then like this. Okay, so we saw that when I graphed sine, remember that day I was freaking out? That like the series matches up to the function for a certain number of values? Shut up. these two things basically collide, but the further away you are from 0, the more error there is. So if I'm all the way over at -1, I'm going to have a lot more error than I am when I'm closer. So this is a formula for the error. So for example, at x equals, say, 0.2, I'm going to have a certain amount of error. But at another x value, I'm going to have more error. Get it? No. So basically, because this thing converges from -1 to 1, the closer I am to 0, the closer, or the more the thing's going to converge. So like here, the series and the function are going to basically be the same. But as I come away from x equals 0 on either side, the series and the function will become less and less similar. And as I get closer and closer to -1 and 1, I'm going to have the biggest difference. And then the series doesn't converge anymore, so it doesn't matter. But from -1 to 1, the amount of error that you have is going to change. So the closer I am to 0, so at x equals 0.2, I already found it. The error is 1, 2, 3, 4, 5, 2, 6. 5 zeros and a 2, 6. Oops, point.
How did you find that though?
By plugging 0.2 into this new series. Okay, if I plug 0.2 into this, I get this tiny decimal. So that means when x equals 0.2, my series and my function differ only a little tiny bit. And actually, sorry, 0.9 is what the other one I computed. At x equals 0.9, I got 2.265. That's a lot more. Yeah.
So to find the error, it would have to be a question that gives you up to what question?
Yes. So for this particular problem, number 1 has to be geometric, and number 2 they have to tell you up to what they want you to look at.
Okay.
So they might say, look at a fourth partial sum, look at the first 4, whatever, cut it off there. What remainder is there? Like or what's the error at a certain x value? Yeah.
So like the range of like what the actual sum of the whole series is like whatever you get when you plug in the value for x into that, and then plus or minus the error.
Say that one more time.
So what the whole series, if you were to go on to infinity, what the whole thing would equal would be like up to that 4th degree when you plug in the
Plus
x.
or minus the error.
Okay.
Yeah. Yep.
So is that like how much it's up or down?
That's how much off it is, up or down. Yep. Okay. It's not that stupid. I mean, it's so silly to quantify this. Who really cares? But they're going to ask you a question about
Why
it.
don't you just add
What
that?
about at 1? Is that just
This converges actually when x is like less than 1. So like at 1, it's not really valid. But at 0.99999999999, you could look. And that error should be bigger still. So at like 0.1, my error would be tinier. At 0.5, the error would be in between these. So the further away I get from 0, the closer I get to 1, the more error I have.
Why doesn't it work?
That's crazy.
At what 1 and...
Why isn't 1 a value?
I don't remember why. I don't know why. But when we said it converged, we said the absolute value of r had to be less than 1. It wasn't equal to, it was just less than. So I'm not exactly sure why it doesn't happen at 1. This is the easier one. We have to do the harder one.
What?
Yeah. When they're not geometric, it's harder.
Wait,
Idiot.
I thought you said it has to be geometric.
To use this.
Oh.
Is this okay?
My
Make sure you digest it before we go.
Or what we're doing after this, does it make more sense with calculus than stuff?
It's still series.
After this test.
After this test is still series, it's telling whether a series converges or not using all these other crazy tests. I'm sorry.
But after that.
Then we're done. That's it.
Wait, we only have 2 more tests?
Yeah.
Wait.
For real?
Yes.
Party!
That's awesome.
When we're having this week, guys.
What's that?
We have to. If we could finish before spring break, however many days left before spring break, we could, but we're not going to.
Let's party. Nachos. Nachos.
Then I got the job.
Where did you apply?
It's Chester.
basically. This is really in Calc 3 classes. They'll put this
Why are we learning it?
It depends on what college you go to, but a lot of colleges will have sequences and series in their Calc 3 class.
So easy. Calc 3. What's in Calc 4?
It's called differential equations, and you go back and you look at like some crazy differential equations.
How about Calc 5?
Linear algebra.
To be honest, it was called advanced calculus. I couldn't even tell you what we did.
Divided by 0.
Wait, then what the heck's linear algebra?
What's that?
Linear algebra?
Linear algebra is just thrown in there. It's not like consecutive. You can take it whenever. Linear algebra is cool. It's like all the matrices and stuff. If you like algebra, linear algebra is great.
I don't like that.
What's that?
How far do you go?
To 5. Calc 5. I was a math major, so I took a lot of math classes.
Oh, geez.
How many calc classes are there?
5.
There aren't any more than that.
So then what comes after that?
Unless you go take your doctorate. I mean, like, so I took topology and I took statistics and I took linear algebra and I took discrete math and I took differential equations.
Discrete math?
Discrete. Oh, no, it's
Like ninja. It's like ninja math.
I don't know. I went to school like for 4 years. Well, I student taught, so like for 3.5 years, I probably took 3 classes a semester. So 1, 2, 3, 4, 5, 6, 7. I took 21 math classes.
Oh my god.
It's a lot of math classes. When you take like 2 or 3 a semester and you can't remember which math class this is from, you're like, was this what class am I doing right now? Like, it's like crazy.
You took 3 math classes a semester?
2 or 3, yeah.
That's not that bad.
No, it's a lot though. It's a lot. Yeah, it's a lot.
Maybe once.
It's a lot. Like, I took number theory. It's another crazy one.
What's that?
I don't know.
It's fun.
That was the teacher in the first day. She's like, most of you aren't going to get A's, so just be ready for that.
Whatever. It's
Of
not what you're
course.
at.
Of course. Stupid. What?
I'm so glad you had I'm glad you got that.
She made me so mad. Alright, you ready?
I like your nose.
A surprising number of teachers say that on the first day.
Like, why? What is the point? Are they trying to scare you? Or just make you feel mad? Or, like, it's supposed to be inspiring? It's so stupid.
I don't know. Maybe it's to mark the ones you're supposed to hate.
Right? Alright, so what did I just write up? Is it anything new?
I don't know.
No. That should be like, oh, nice. This is just the Taylor polynomial formula, okay? This is just the Taylor polynomial formula centered at A. Okay, so this can be centered anywhere. It doesn't have to be centered at 0. If it was at 0, you wouldn't have any of those A's. It would just be X to the whatever. But this is a Taylor polynomial. So the idea is, if you have a Taylor polynomial, first term, second term, third term, whatever, here's my nth term. Even though that's my nth term, I still can have another term. And a Taylor polynomial is defined for all of its terms up until like the nth term. The nth term is where like infinity happens. But even beyond that, you can always have more because, we're going to infinity.
Infinity's bulletproof.
Isn't infinity considered that?
What's infinity in Roman numerals?
So whatever comes after my nth term, I'm going to call like my remainder. And this is kind of like the leftover stuff, and this is kind of quantifying the error. Well, they basically let you quantify the error by talking about the term that comes after the last term. So if we consider n to be the last term, there's still one that comes after it, right? So it is f, and then the derivative is the n plus 1 derivative, evaluated at a, times x minus a to the n plus 1 over n plus 1 factorial. The only difference is they're going to take out this a
No.
and put in a c, because
Yeah.
c can change.
Because that's what you're getting.
Shut up, I'm getting there.
C equals a number between.
Oh, not 6. Shut up. It's an high school.
Between X and A. What?
Yeah.
Ah.
This forms,
What if X is A?
And then you give me
then you would plug that in.
That's not
But we'll get there. This is called the Lagrange. It was so fancy I had to write in cursive. Form of the Riemann. Okay. When you see a problem, they will probably ask you for the Lagrange form of the remainder, which should be your clue that this is like a Taylor polynomial, and I'm going to be finding this term, this n plus 1th term. The reason why this C can vary is because they're going to not always be specific. And they're asking you to find what the biggest possible error is. For example, the last problem we just did, don't write this down, but when we had x to the 8th over 1 minus x squared, they might give you an interval, like when x is between 0 and 0.5, what's the error? Well, there's obviously a ton of different errors that go from 0 to 0.5 in that last problem, right? I could have plugged in any number between 0 and 0.5 and gotten an error. They're going to want you to find the biggest possible error. So whatever number would have, like for this one, what would I plug in? 0.5. I plug in 0.5, and that would give me like the biggest possible error for that problem. That's why C can vary, because I'm going to be using numbers here. I'm going to choose the number that's going to give me the biggest possible error, and that's why the C can change. No, it's, what do you mean?
So if you change C, you have to change X.
No, you'll see how it works. Let's look at it.
We'll see.
So
What
let's,
tattoo is that on your shoulder?
Ooh, pretty.
Because it kind of looks like a Dr. Seuss thing at the
It's
end.
not.
What's cut off?
it's not.
What's this?
It's dirty. Just kidding.
Wait, what's this?
I don't know.
She doesn't remember. It was a fuzzy night.
On your shoulder.
It's a tattoo, and Zach's asking me about it, because
Well, I'm just saying.
I ask everybody about the tattoo.
It's
There
a-
is a tattoo.
I've already, it's like for my son, which now I say is for both my sons, because I never got like a second one for my second son, so.
So you don't
Did you love it less?
Let's see it.
Where's
No.
the tattoo for me?
Corey, never mind. I can't think of something that you're not going to take the moment.
You're so look at everyone look at Hope. She looks like a goo.
The series for the natural log of 1 plus x is one of those you're supposed to have memorized. Do you remember what it is?
Zach Bryson.
Wait.
Zach Bryson.
Do you remember what it is? If you look on the yellow
Yes,
paper,
it's X
line
is
it.
X squared over 2
X
plus
plus
X.
2X.
I'm going to stop there. I'm just going to go 2 terms.
Okay, so.
And then it would be plus x to the third of 3, blah, blah, blah. They're going to ask you to find the error. When x is between negative 0.1 and 0.1. Now, natural log of x, I don't remember actually. Does that converge? No, that only converges from x equals 1 to negative 1. So they want to know what's the error when we're only at x equals 0.1 and negative 0.1. But I've only given 2 terms. So the errors, I mean, still could be small, but I'm going to have some error. Okay, I haven't even given that many terms of the series. Do you get the big concept that, like, the more terms of the series, the smaller error I'm going to have? They're going to make you cut the series off at a certain point and ask you to find the error. There's always going to be some, because I never am going to have an infinite number of terms. But the error will be smaller the closer I am to 0, and it'll also be smaller the more terms I have. So those are 2 ways to make the error smaller. Give more terms, or give an x value close to 0, and that'll give you less error. So, to find the error, I'm going to just try to use this formula. I'm going to try to use the derivative, the n plus 1 derivative at some value c, times x minus a to the n plus 1 over n plus 1. First of all, what's n? N is the number that I went up to. So what power did I go up to? So my n here equals 2. So I'm looking for the third derivative, and I'm going to be plugging 2 into the n spot. So however many terms they're giving, whatever power that is what nth term I have. Does that make sense? So, sure. I want to know first, what is n? Well, n is the nth term that I went up to in the series. So 2 terms, my n is 2. So therefore, if I'm going to rewrite this formula, my bottom number is n plus 1. And then this is centered at 0. So I have x minus 0 to the... Oh, sorry. Thank you.
Got that.
Okay.
Hey, it's centered around 0.
Should we put 3 or just leave it as 2?
Put it as 3. I just wanted you to see where I got it from. Okay, so yeah, go ahead and write that as 3.
2 plus 1.
And what I'm trying to find then is this number. Okay. So what I'm looking for, in fact, instead of writing it this way, let me just write it as, I'm looking for the third derivative at some point c. So I'm going to go find some derivatives. Well, if f of x is the natural log of 1 plus x, I'm going to find f single prime, I'm going to find second, and I got to find the third.
No.
Yeah. So f prime is 1 over 1 plus x. Agreed? Okay. And this is really 1 plus x to the negative first. It's easier just to write it that way. So the second derivative is negative 1 plus x to the negative second. And the third one is 2, 1 plus x to the negative third. And now I'll write it normal because I'm finished. Okay. The idea is, I want to get a number out of this. Okay, I want to actually be able to get a number. And I still have some stuff to plug in. What I want to plug in for the third derivative at some value c, well, I said c is an x value, right? Well, they're giving me an interval in which I'm supposed to plug in for x. X is between negative 0.1 and 0.1. I want to plug in a value for this x so I can get a number. And I want to plug in whatever x is going to give me the largest value for that number. Because I'm looking for error, and I want to answer them with the biggest error possible, because then I'm at least overcompensating for the error. What I plug in for this should be as big as I can get it to be. So I can plug in anything from negative 0.1 to 0.1. What value will give me the biggest number for error? You're always going to be given restrictions, yeah. Or they could give you an exact x value. If they say find the error when x is 0.2, you're just going to plug in 0.2. But if they say find the error on some interval, I'm going to plug in the x in that interval that gives me the largest error. So what did you guys say? Negative 0.1?
No,
Jim.
Jim.
Why? You want small and make big.
He said.
Couldn't it be both?
Because if I was...
That would make the
Yeah,
denominator
no. So
bigger.
this is going to be 0.9. And if it's a decimal and I'm cubing it, I want the smaller... I don't want it to be 1.1 to the third?
No.
Oh, because it's on the bottom. So I want the bottom to be as small as possible, right? If you're not sure, try both of them. You'll have a calculator, see which one gives you the smallest one. So when I do this, I get 2.7434. It is, I know. Okay, so again, to figure out what x, use a calculator, plug in 0.1, plug in negative 0.1, and whichever one gives you the bigger number, use that. So this is what I'm going to use over here as the whole thing, the third derivative at c. Okay, that is the third derivative evaluated at the x that I plugged in. I know. So the remainder is, this is our number we just found, 2.7434. And now, same thing over here. I want to plug in the x is going to give me the largest error. So do I plug in negative 0.1 or 0.1? Yeah, it says, because negative 0.1 is going to give me a negative number when I raise this to the third. So I want to plug in 0.1 to the third over 3 factorial. What's that? Then it doesn't matter. Push that into that super fancy calculator, and you get 0. So the idea is, if I have the function natural log of 1 plus x, and I only graph the first two terms of the series, if the series were infinite, the series would look exactly like the natural log of 1 plus x. The series can't be infinite. If I cut it off at this spot, when I'm only on the interval negative 0.1 to 0.1, so like say it looks like this or whatever, from here to here, the most that my series is going to differ from my real function is this little tiny amount. That's the maximum I could be wrong as far as the gap between the real function and the series function when I graph it from negative 0.1
So
to 1.
is there a point where it gets that far away?
That gets this far away? Yeah, that's probably happening at 0.1. Yeah.
Or negative
Or negative 0.1. It's probably happening at both. I don't know. I'd have to look and see what the graph actually looks like.
For negative 0.1, it would be the negative of that.
It would be what?
It would be that, the distance, because, whoops. It would be that distance because if you just plugged in negative 0.1, it would just make that
Be a
negative.
negative amount, so
But since
it doesn't really matter. 'Cause it could be an error in either direction.
but like,
There you go.
don't you think the x's should
Match?
see?
Yeah, they don't have to.
Ew.
So the biggest absolute value of this.
So is that it?
That's it. Try a couple problems and see how they go. I only give it a couple.
Okay, can I ask a question? Sure. It's mostly just like concepts.
Okay.
Every morning he looks and says, "Don't call him." I know, obviously, if you talk about just go, absolutely. Have you had it? No, I just saw it pretty on my phone. Disgusting.
What are we doing Thursday?
Reviewing.
I don't think I want to miss that.
Try those three. See how it goes.
That says page 486, try numbers 11, 13, and 15.
Tomorrow we'll go over this, and I'll probably give you some review stuff. And